It's time to learn some more coding using Pico-8, and this week we're going to be talking about functions, so let's get right into it. Welcome to episode 5 of Pico-8pril, and we are learning how to code by using Pico-8 all this month, every Monday and Friday. So this episode we're going to be dealing with functions, but before we do that, I gave you a challenge at the end of episode 4. And that challenge was to make this happen. So we learned all about graphics last episode, and I challenged you guys to make this. So lots of different ways to doing this. Not a very efficient way using just what we learned in the last episode, but this particular task is going to get easier and easier as you learn more and more about coding. So let's look at how I solved this. Maybe you solved it a little bit differently. But basically what I wanted was a gray background or some solid colored background and then a 3x3 checkerboard drawn out. So let's take a look at what we got here. So of course we start off with the CLS. So we're clearing the screen. In this case I use 6, which is that gray color. So that takes care of that. And since it is the first thing that happens, it's going to be at the very bottom. It's going to happen first. And then basically I just got 9 rectangles alternating colors between 10 and 0, and 10 and 0 here are going to be, if we look at our colors again, here's 10, which is yellow, and 0 is black. So that's how we got the colors to alternate back and forth. And then all these rectangles, or squares in this case, are just hard-coded to be starting at these XY coordinates, ending at these XY coordinates, and then you just have to do the math to figure out how to get them to line up 3x3. So I started at the top and worked my way all the way down, and that's how we did it. Now you could have just made a big yellow box and then put 4, did the math and did 4 squares on top of that, and that would have done the same thing. Would have been a lot easier, but maybe the math's a little bit harder on that one. So I hope everybody had fun with that. If you need any further explanation, then go ahead and ask down in the comments below. I'll be happy to explain how it was that we did that. So let's get rid of this and let's get right into this week's topic. So for this episode, we're going to be talking about functions, and functions I think are very important because this is where when I learned about functions or methods, depending on what you call them, this is where I really started to feel like a programmer or a coder. Anybody can Google what's the command to clear the screen, or Google how do I draw a circle in Pico-8, find that code, paste it into Pico-8, and make that circle. Anybody can do that. But what we really want to do with programs is to solve problems. We've got something that we want to do, whether it's a game or some kind of accounting program or whatever it is. We've got something that we want to do and we want to figure out how to do it. And this is how we solve those problems, by using functions. So we've already talked about our programs having built-in functions. Those are the functions that are built into Pico-8, and they do very important things. And now we're going to be making our own functions. And in some cases, it's going to be just to keep the code clean and segregate things out. In some cases, it's going to be to save a lot of time and effort if you're going to be doing something over and over and over again. So let's start off with kind of where we ended up last episode. And this is the basically what we were drawing to the screen. So if I run this again, you can see we learned about making the pixels on the screen and drawing some squares. We drew some squares just with a bunch of pixels. We drew some with some lines, and then we did an actual rect fill, which was, or a rectangle to actually make the square. And then we did some circles. We overlapped some circles on top of each other. And then we put that line in there. Well, let's get rid of this silly line that's going right through the middle of the screen. So if we look back at the code, you can see that I put that line right here. It's the one that's starting at 0, 0 and going to 127, 127. And if you want to get rid of it, you can just delete it. Or if you want to just temporarily get rid of it, you can put the 2 dashes, which is how we make comments, and just comment that out. And you can see it turned gray right away, and it no longer gets gets executed. So starting here, you can see I've got all these lines doing all this code, and maybe I want to start doing things a little bit smarter. So here I've made 4 circles, which make this donut show up right in the middle of the screen. And we started with those 4 circles at 64, 64. And I talked about replacing these with variables. And then we actually did define some variables up at the top. I went ahead and took those back out. And you could define some variables so you can change that. But what if you want to do this over and over again? What if I want to put a bunch of donuts on the screen and, I don't want to manually type these all out and edit them? What if we just made a donut function? So far we know we have these 3 functions, the init, the update, and the draw. And we see how they are defined, right? You define it by saying function, you give it a name, you open and close the parentheses, and then you have an end. So everything in the middle here is going to be part of that function. So if I wanted to make a donut function, then I would just start anywhere down here and say function donut, open and close parentheses, and then type end, and then everything in here would be that donut. Now, I can just take this right here and cut it and paste it right into here. So essentially we still have the same code. We just put it in a function now. And now when we run the program, where'd our donut go? Well, the next thing we have to do is we actually call that function. So somewhere we want to call that function. So by calling a function, just like I said that this clear screen is really a function, and these print statements and pset statements are really functions. They're kind of built-in commands. But this is the same format that you would use. To call the function, you just figure out where you want to call it, and you type in the name of your function. And by putting those parentheses in there, it knows, hey, this is a function that they're calling, not just a variable. So in this case, it just says, hey, do all this stuff here in the draw. And then when I get here, jump down to this function and do whatever's inside there. And then once it's done there, it's going to continue down the rest of the program. Now, there is nothing left in the rest of this program. In fact, actually, I defined this function accidentally inside the draw, which is not good. So we'll go ahead and put that back down here. So it's going to go ahead and call this donut function, do all this stuff, and then pop right back up here. And if there was more commands down here, it'd go ahead and keep on going until it hit the end. So then it's going to loop through. So let's go ahead and see if that worked now. And there we go. We got our donut back right where it was. So we really did nothing except for just take this that we already had, these 4 commands that we already had in here, and give them their own function. And at this point, there's no benefit to that. But what if I wanted many donuts? What if I wanted to do this over and over again? Being able to call this function over and over again would be great. Right now, it does no good for us because it's just going to, if we called it again, it's just going to put it right on top of the other one. So that's no good. Maybe I want donuts in different places. Well, if I want donuts in different places, this is where we're going to have to start changing the values of these 2. So this is X and Y, remember, which is going to be the center point of our circle. So if we want to change the location of those 2, we could either hard code it like we did before and just come up here and say donut X and donut Y. But that doesn't do us any good. What we're going to do is we're going to call the function and we're going to define the X and Y at the same time. So inside these parentheses, just like we have all this stuff, all this information inside this rect function or this rect command, telling it, hey, where's the X and Y and what color do you want and all that stuff that we learned about last episode. Let's go ahead and do this. When we define the function, we can put some variables in here. Let's just say X and Y. And if we do that, Pico-8 is going to be expecting to see this information when we call it in here. So I have to actually put something in here, and let's go ahead and do 64 and 64. Well, let's do 30 and 30 just to make it different. So I'm telling it, hey, call the donut function and include this information in there. And that's called passing variables or defining parameters to the function itself. So it's saying, hey, call donut function, x of the function is going to be equal to 30, and then y is going to be equal to 30. Now, right now, nothing's going to happen. If I run this program again, it's still putting it at 64, and that's because I'm not using this x and y anywhere inside the function. And it didn't give me an error because it doesn't know I want to. Just because I gave it variables doesn't mean it needs to use them. So in this case, we're actually going to take and replace all these x and y values that we hard-coded in here, and we're going to replace them with x and y. So let's go ahead and get rid of 64, give it xy, and now when we run it, it's going to pass these variables 30 and 30 into here. It's got a place to actually use them, and boom. Instead of being at 64, it's at 30 and 30. So now at this point, we could, in fact, call this function several times. And let's go ahead and call it at 64. And let's call it at 90. So now I'm calling it 3 times. I'm giving it 3 different sets of x and y coordinates, and it's still inside the draw loop, so it's going to happen one right after another. And there we go. We got multiple donuts on the screen. So instead of having, for each one of these donuts, it would have taken 4 lines. Instead of having 12 lines of circ fills coming down in our draw function, we've really only got these, the function defined, and then we've got these 3 donut commands being called, these functions being called. So that's where you start to see some of the benefits of a function when you need to do something over and over again, but you need to do it with different parameters each time. Now, if you just only needed it at 64 ever, then you could just leave that in here and we don't need to pass variables in there. But in this case, we wanted to put it in 3 different places, so now we got a way to do that. So we could do the same thing with a square. We can make a function for a square. Before we have one, it's called rectfill, which makes a rectangle. And if we look at, let's look at this rect line right here. We've got the starting x, the starting y, the ending x, and the ending y. And then we could define also a color variable after that. So if we wanted to not worry about figuring out where we need it to start and end, we just want to know, we want it to start at a certain place and we want it to be a certain size. Let's see how we can do that, and let's clean up some of this here. And let's make a function named square. Now, I said I just wanted to have an x and a y of where it's going to start, and then I just want a size. So let's call that W for width, like how wide it's going to be. And maybe I do want to define a color also. So let's call it with a C. So now when I call this square function, and I can start to type it out here, I know I need to give it 4 things: a starting location, X and Y, how wide I want it in pixels, and what color I want it. So how are we going to make that work? Let's say I want one right at 64. Let's say 64, and I want it 30 pixels wide, and let's pick a nice color for it. Let's do this kind of purple color, so 13. So now I'm calling it. Now I have to actually create the function here. So to get a square, we know it's really just a rectangle, but we know all the sides are going to be the same size. So let's start off with our rectangle here and figure out how we're going to do this. Well, we got the starting X and the starting Y, and that's going to be passed in when we call it. So 64. So we got that. How are we going to get the width here? if we're given the width, how are we going to know the ending coordinates? Because we're using the built-in rectangle function, and we need the ending coordinates for it to draw this thing out. Well, the ending coordinates are really, if it's going to be, in this case, 30 pixels wide, it's going to start at X, and it's going to be 30 more to the right, and it's going to start at Y, and it's going to be 30 more below. So if that 30 is the width, and we only need one because for a square, it's the same on each side, we can just make this X plus the width, and then Y plus the width, and that's going to be my ending coordinates. It's going to start at X, and it's going to be 30 wider, and it's going to start at Y, and it's going to be 30 taller. So the last thing we need to do is add in the color, and the next command that we can use for that would have been the color. So now it's getting the X, the Y, the W, and the C all from here, which is coming all from here. So let's see if we got ourselves a square. And there it is. So it's starting right in the middle. The top left corner of that purple square is right at 6464. And that's 30 pixels wide, 30 pixels tall. And it is that kind of pale purple color. So now we got a square function that we can duplicate over and over again. Let's do it at, let's say 10. Let's do it at 100, 100. Make it only 10 tall, and make it color 8. So there it is, that kind of reddish colored one starting at 100, 100 and 10 pixels wide. So now, if we wanted to, we could change this to a rect fill if we really wanted to fill these things in. And you can see now how making the challenge for last week would have been a little bit easier, because we're just going to make a square function 9 times. And instead of doing the math ourselves, we're just going to do the math for us. We just need to know the starting location of each one. So we'll let Pico-8 do all the math on what the ending coordinates need to be, because that's really the part that I hate about defining a rectangle or a square. I just want to define the starting location and how wide you want it and how tall you want it. So if we really wanted this to be a true rectangle, we could add a width and a height and then do Y plus H. But for square, it's just the same size for both. So now we got a function for donuts. We got a function for squares. Not super practical in any type of sense, but we're going to be using that same type of thing over and over again as we start making more complex programs. So let's add here at the end just a kind of a practical application. So let's go ahead and see what we're doing here. We got a bunch of stuff on the screen, and we can easily comment this stuff out. So I commented out all my donuts and squares. Let's go ahead and, like I said, make a practical function. So let's say I've got a job at a donut factory, and I'm making donuts all day long, and I want to know what my paycheck's going to be. So to figure out my paycheck, I need to know how much I make per hour. So let's call that rate. And let's say I'm making $12 per hour at this donut factory, and I need to know how many hours I'm working. So I'm making $40 or 40. I'm working 40 hours a week. So now I want to figure out my paycheck. So let's make a function called calc_pay. And of course we need to define that as a function. And in this function, we're going to figure out what the pay is, but then we're going to have to print it on the screen so that I know how much I'm going to get in my paycheck. So I want to print to the screen up here my paycheck will be, and remember we learned all about this in I think episode 2 and 3, how to concatenate in information. Well, I could either make a variable, define a variable, and do that, or I can do this right in line and call the function right from here. So I can, what do we call that? Calc pay. So I can call calc pay, give it some information, and then let's close out this print statement. And let's go ahead and add in a $sign right here just before the dollar amount. And to do this, we're going to pass in the variables rate and hours, because that's what we defined up at the front. Oops. So rate and hours. So we know down here in our function, we're going to be receiving two things. Now, we don't have to make this the same variable as what we called it with, because we could have just been putting numbers in there. These variables right here that you define when you define the function, they are for use just inside the function. So like this X, Y, W, and C, they're only used in here. So their scope, that you call it, their scope is just inside the function. Once the function ends, it forgets all about these. You could actually define X outside of here, and it would not affect this, and this would not affect the X that you defined outside of there. Now, I like to try to keep things simple in here and make them not overlap with other variables in the program. But in this case, we've got a variable for rate and hours. When I'm making a function, I usually try to make these small, but make them somewhat understandable. So R for rate, H for hours. And so in here, all I have to do is calculate out what my pay is. So let's say paycheck equals R times H. So it's that simple, right? The amount of money you make per hour times the amount of hours that you're working, that's going to be your paycheck. So right now, it's got an amount inside here called paycheck, and this is just lives inside this function. And we need to get it outside this function back to where it got called. So what we're going to do, if we call a function with variables, we can also return a value back to where it got called. So in this case, we're going to say return paycheck. So this says, take the information that we got, do what you need to do with it, and then return this. Now, you can return multiple things. You can return something that's completely different than what you actually calculated, but it makes the most sense that, hey, we wanted to calculate our pay. That's exactly what we did. Let's return the answer. So that paycheck, whatever number is assigned to this paycheck, is going to go all the way back up here and end up right where we called it, right here. So it's going to basically put the value of paycheck right here. Now, it's not going to actually be paycheck because that variable only lives inside that function, but whatever number it computed is going to end up right here. So let's go ahead and run this and see if it worked. Now, of course, it's overlapped right over those squares that we had. So let's go ahead and get rid of some of these squares. We'll go ahead and just wipe all this out. And run it. And it says my paycheck will be $480. And that is exactly right. Now we can go back in here and change these values. Maybe I get a pay raise to $14 an hour. And now I can see my paycheck will be $560. So that's all because we took this print statement here. My paycheck will be, and then we can concatenate it in whatever this is. Now this makes for a very long line. You can see how it's kind of a pain in the butt to scroll back and forth. So what you could do here is you could just define this variable pay and make a new variable, make that equal to all this nonsense right here. and then just put pay in there. So here's pay equals. So I'm going to have a new variable called pay. It's going to equal to whatever happens when I call this function. And when I call this function and pass rate in hours, it's going to go ahead and take that information down to my function that I created, and it's going to return paycheck. So that return of paycheck is going to end up right here now instead of in the middle of the text. And then now that I've done that, this line's a little bit more manageable because now I'm saying my paycheck will be, and it will just be whatever this pay is equal to. So it does the same exact thing. It just makes it a little bit easier to read. Instead of doing it on all one long line, now I know here's pay. Let's go ahead and put that pay right in here. That way, if I need to troubleshoot and fix anything, I'm fixing it right here and not at the end of a big long text line. So hopefully that made sense, that you can create your own functions, pass it variables that you want to pass it, have it compute some stuff or have it do something. In this case, the donut function is just drawing a donut for you. In this case, the square function is just drawing a square. And this function calc pay is actually doing some math for you and returning an answer. So that's, like I said, starting to make functions is kind of like starting to make pieces of a puzzle that you can all put together to get the big picture that you want. And this is a good time to also talk about how maybe you just want to have your three main functions on this tab and start putting all my custom functions over on this tab, and then kind of keep them separated out just to keep the lines, nice and tidy. So hopefully that all made sense. If it didn't, ask me any questions you want down in the comments. I'll be happy to help you out with those. But using what we learned today with functions, guess what time it is? It's time for a challenge. All right, for this week's challenge, I want you to take what you've learned this week about functions, and you're going to do this. We've got 3 different checkerboards, 3 different sizes, 3 different starting locations, and we're going to do that by creating a function called checker. So that's what your challenge is. So you can see we've got nothing in the init, nothing in the update. We clear the screen, and we call this checker function 3 times. Now this checker function has several things that we're going to give it. We're going to pass those into the function. So we have the starting X and starting Y. And I'll type this up here. So that's your X and your Y. The next one's going to be the width. And then you've got your color 1 and your color 2. So you're going to define the starting location, how wide you want each of the 9 boxes that's going to get drawn, and then what color you want to alternate between. These 2 colors are going to be what ends up being the 2 colors of each of those checkerboards. So you can see we've already defined what this is going to look like. You just need to create the function itself. Now I've created it. I've put it right over here hidden from you guys, but you're going to go ahead and do that. Now you can keep using the square function here because really that's going to be the easiest. And you can use the square function inside your checker function. So this is making a rect fill with your starting Y, your starting X and Y. It's going to create the endpoints for you and give it the color. So really, I'll give you a hint. This checker function is just going to be 9 of these. You just have to do the math to figure out how it's going to make those 9 boxes end up in a checkerboard like this. So you can see that I simply just changed the starting location of each one. I changed the width of each one, starting small and getting bigger. And then I changed the 2 colors that are alternating between those 2. So make yourself a checker function. It's going to use some trial. It's going to be some trial and error. Even as I was typing it up just now, I messed it up and found the problem, and then it looked right again. So have fun with that. Challenge yourself with it. Make some checkerboards. Have some fun and put them all over the screen. And good luck with that. Let us know how you do down in the comments below. So that is going to wrap it up for this episode. Hope you had fun learning about functions and making functions. Like I said, it's going to be something that we're going to do over and over again. Anytime we get to a point in the program that we're like, well, I don't want to do this over and over again. Let's just make a function and clean up the code a little bit. So that's what we learned. Hopefully it made sense to you guys. Thank you as always for watching. And until next time, peace out and geek out.